Hello everyone, today we will be finishing up our discussion of data representation with an overview of ranges and standard deviation. So we'll start by looking at ranges. So if you remember from the last video, we have this example data set that we've been looking at for our ratings for a really terrible movie. And we, in the last video, figured out our 5-number summary, which includes the minimum, maximum, our quartiles, which are our 25th and 75th percentiles, and then the median, which is our 50th percentile. So the first data metric that we'll look at is the range. Now, the range is basically just the maximum minus the minimum. So in this case, our maximum is 5 and our minimum is 1. So our range is just going to be 5 minus 1 or 4. This is not always the most useful metric, especially when you have data sets that have outliers in them, which this one does. Oftentimes a more useful metric is the interquartile range, which we abbreviate IQR. This is basically just our upper quartile Q3 minus our lower quartile Q1. So in this case, Q3 is 3, Q1 is 1.75. So if we do 3 minus 1.75, that gives us an interquartile range of 1.25. The range and IQR are both ways that we can sort of help measure the spread of a data set. Another very common way that we'll see for measuring the spread of a data set is the standard deviation. So the standard deviation, I have a set of 5 numbers up here. We're going to use a smaller data set for this because standard deviations can get really time consuming when you're trying to do them by hand for larger data sets, basically. So in this case, the first thing that we're going to do is we're going to take all of our data points and we're going to calculate the average. So the average, as you may remember from the last video, we're going to add up all of our data points and then divide by the total number of data points. So if we add all of these up, we get 31. Divided by our total number of data points, so 5. So this should give us 6.2 as our average. The next step is we are going to figure out what we call the deviations. The deviations are basically just how far away from the average are all of our data points. So what we're going to do is we're going to do x minus a for all of these. So 1 minus 6.2, that would be negative 5.2. Three minus 6.2, that would be negative 3.2. 6 minus 6.2, negative 0.2. 8 minus 6.2, that would be 1.8. And then 13 minus 6.2, that would be 6.8. So this next step is where it becomes really handy to have list functions on your calculator. It makes this step a lot faster. If you don't, you can of course just square every individual one of these and then take the average of all of them is the next step that we're going to do. So what we would do in this case is we are going to square all of these deviations that we just calculated in the last step. So what we get if we do that we get 27 0.04, 10.24, 0.04, 3.24, 46.24. So these are basically just the squares of all of these that we found in the last step. The next step is we're going to calculate the variance. So the variance is basically just the average of all of our squared deviations. So what we're going to do is we're going to take all of our squared deviations, so 27.04, 10.24, 0.04, 3.24, we're going to add all of these up and divide them by our total number of data points, which is still 5. So what that gives us is a variance of 17.36. And then all the standard deviation is just the square root of our variance. So we're just going to take the square root of 17.36, which is going to be 4.1665. So this would be the standard deviation of our data set. Thank you for watching, and as always, I'm happy to help with any questions you may have.